Hello friends, in this video we will know about the sign conventions used in case of spherical mirrors. Sign conventions are the positive or negative symbols that we attach to object distance, image distance or focal length, height of object, height of image while solving numerical problems on mirrors or lenses. The sign conventions for spherical mirrors and spherical lenses are same, except in case of spherical mirrors, the center of the mirror will be called as a pole and the center of the lens will be or is called or known as optic center. So before starting the sign conventions, let us introduce us to the physical quantities to which we are going to attach the sign conventions. So let U represent the object distance. And what is the meaning of object distance? Object distance is the distance between object and pole of the mirror. V represents image distance. Image distance is the distance between image and pole of the mirror. So by this time one sign convention is automatically understood that all distances are measured from a pole of the mirror. That means center of the mirror or optic center of the lens. So all distances are measured from pole of the mirror. That's one of the sign conventions. However, F represents focal length. And what is focal length? Focal length is the distance between principal focus of the mirror or lens and pole of the mirror or optic center of the lens. H subscript O represents height or size of object. And H subscript I represents height or size of image. Other than these, the alphabet M represents magnification produced by a mirror or a lens. We will discuss in detail related to magnification. So watch until the end of the video because I will be representing or presenting a tabular form that will ease the sign convention understanding. So sign conventions for spherical mirrors or lenses are based on the way the Cartesian plane rules exist. Cartesian plane means the imaginary plane made by or imagined by René Descartes, where a horizontal line and a vertical line divide the plane into 4 equal parts. The horizontal line is known as x-axis and the vertical line is known as a y-axis. The point of intersection of the horizontal and vertical line is known as origin. And according to René Descartes, all distances to the right of origin or right of y-axis, take it, and above x-axis are taken positive. And all distances to the left of origin or left of y-axis and below x-axis are taken negative. So you must be remembering how we do the numbering on these x-axis and y-axis. So right side we write +1, +2, +3, +4, +5 like this. And left side we write -1, -2, -3, -4. Similarly, on y-axis, above line we write +1, +2, +3, +4 and below origin on y-axis we write -1, -2, -3, -4 like this. It goes on. So this is how the sign convention in case of spherical mirrors also work. So spherical mirrors are the concave mirror and the convex mirror. In the previous video we have defined or we have understood what is a spherical mirror or what is a concave mirror or convex mirror. Concave mirror is a part of hollow sphere whose outside is painted and inside is a reflecting surface. And convex mirror is a part of, or it is a spherical mirror which is a part of a hollow sphere whose inside is painted and outside is reflecting surface. So while drawing the ray diagrams or while solving the numerical problems, one point very clearly remember that the reflecting surface must face left side. Okay, so now I'm drawing the principal axis for concave mirror as well as a convex mirror. Principal axis is the imaginary line joining center of curvature and pole of the mirror. So an imaginary line that joins center of curvature and pole of the mirror is known as principal axis. So according to sign conventions, the first point, all distances are measured from pole of the mirror. All distances we measure from pole of the mirror in case of both the mirrors. And all distances above principal axis and to the right side of the mirror, above principal axis and right side of the mirror are taken positive. In case of both the mirrors, above principal axis, all distances are positive and right side of the mirror is taken positive. Similarly, all distances below principal axis and to the left of the mirror are taken negative. Both in case of both the mirrors, below principal axis and left of the mirror are taken negative. So these are the three basic sign conventions, and let me write the points on sign conventions. The first point is all distances. Distances means object distance, image distance, focal length, height of object, height of image, those all. All distances are measured. All distances are measured from the pole of the mirror. Second point is all distances to the right, all distances to the right of mirror and above principal axis. All distances to the right of mirror and above principal axis are taken positive. And the third and last sign convention is all distances to the left of mirror and below principal axis are taken negative. So these three are called sign conventions. Now consider only one spherical mirror, that may be a concave mirror or convex mirror. So with respect to this one mirror, let us start discussing the sign conventions. So according to sign conventions, all distances to the right of the mirror and above principal axis. So above means that above can be whichever side, are taken positive, and all distances to the left of the mirror and below principal axis. The below can be anywhere, left side, right side, are taken negative. And all distances are measured from pole of the mirror. So distance between pole and object is known as object distance. Distance between pole and image is known as image distance, like that. To be more specific, let us have a tabular form for the sign convention. So let me call it as specific notes, which I will provide in form of a table. So let us have the tabular form of sign conventions for the two spherical mirrors: concave mirror, convex mirror. And for these mirrors, let us first talk about focal length, then object distance, image distance, height of object, and height of image. So for these all, let us write the sign convention. Sign convention means we are only telling that when you see concave mirror or convex mirror, for this particular physical quantity, you can put the symbol. Okay, so now just quickly recapitulate. In case of concave mirror, the parallel beam of light rays after reflection were converging to a point on principal axis, which is known as the principal focus. And in case of concave mirror, if parallel beam of light rays are incident on the mirror, they converge or they pass through a point that is called focal principal focus, and this principal focus is to the left side of the mirror. So concave mirror, in case of concave mirror, also in case of concave lens, focal length is a negative. Why? Because all distances to the left of the mirror are taken negative. But in case of convex mirror, the parallel beam of light rays after reflection appear to diverge from a point on principal axis. That point is known as principal focus, and distance between principal focus and pole of the mirror is called focal length. But this length is to the right. This length is to the right of the mirror, and all distances to the right side of the mirror are considered positive. So for convex mirror as well as lens, focal length is always taken positive. Now, the important part of a sign convention is object. The reflecting surface always must face left side. That means object is always placed to the left of the mirror. And left means all distances to the left side are taken negative. So always keep in mind that object distance, whichever be the lens or a mirror or lens, is always, object distance is always a negative for spherical mirrors and lenses. In case of a concave mirror, the first 5 cases of image formation, that is object at infinity, beyond C, at C, between C and F, and at F, all these cases image always formed left side real inverted. So first to 5th case, image distance is negative. Only the last case, that is the 6th case, image is formed inside the mirror. The dentist mirror or the shaving mirror ray diagram, when object is between F and P, image forms inside the mirror, virtual erect. Inside the mirror means to the right side. So the 6th case, image distance is positive. In case of convex mirror, wherever the object is, image always forms. If object is at infinite, image forms at or on F. And if object is between infinity and pole, image always forms between F and P. So wherever the object is, image always forms in the right side. So convex mirror, image distance is always positive. It is always positive. Why? Because image always forms to the right of the mirror. And in case of all the ray diagrams, the way we spoke, that object is placed to the left side. Similarly, height of object also, object is always placed above principal axis. So height of object, since it is above principal axis, all distances above principal axis are taken positive. So height of object is always positive, whichever be the mirror or a lens. In case of concave mirror, the first 5 cases, image is formed below principal axis, and all distances below principal axis are taken negative. Only in the last case, that is the 6th case, when object is between F and P, image is formed inside the mirror, virtual erect, and erect images height is taken positive since it forms above principal axis. Convex mirror, in case of convex mirror, image always is virtual and erect. Virtual and erect. Erect means it is formed above the principal axis, though small in size. So in case of convex mirror, height of image is always positive. So this one table will guide a lot for the image formations. Now let us see some specific particular points on magnification. This is really important. So some important point, further specific notes on magnification. So this point is really important. If say on solving we get magnification as +1, or it is given in the question that magnification is +1, what does it mean? Its meaning is, there are two meanings. We have to explain the sign convention as well as the number. Magnification, whenever it is a plus, its meaning is image is virtual and erect. And magnification number, whenever it comes as a 1, it indicates, if magnification number is a 1, it indicates that height of image is equal to height of object. So these two things has to be understood when magnification number and symbol is given. And magnification +1 is only possible in case of a plane mirror. In case of plane mirror, always virtual erect image of the object forms, and always we see that height of image and height of object are same. So magnification +1, whenever it is said, we should understand that it is about plane mirror only, image formation in case of plane mirror only. The next point to be understood is, if a magnification is a -1, then what we should understand? Minus symbol of magnification indicates that image is real and inverted. I hope by this time we must be knowing the difference between real and virtual image. Real images are images which are formed by actual intersection of reflected or refracted light rays. Virtual images are images which are formed without actual intersection of reflected or refracted light rays. So here magnification negative clearly indicates that image is real and all real images are inverted. And magnification 1 obviously indicates that height of image is equal to height of object. And magnification is equal to -1 is only possible in case of concave mirror image formation when object is at C, when position of object is at the center of curvature. Let me quickly draw the ray diagram for this so that you can connect to what I'm talking. In case of a concave mirror, when object is placed at the center of curvature, image also forms at center of curvature. So this is a ray diagram, parallel beam of light ray. After reflection passes through principal focus, and if a ray is passing through principal focus, then after reflection it goes parallel to principal axis. So these are the two reflected light rays, and where the reflected light rays intersect, there the image forms. So image forms are here. And if object, this is the location of object. So this is height of object and this is height of image. So if object is at C, then height of object and height of image will be same. But image is inverted. So, and this image is formed by actual intersection of the reflected light rays. So real and inverted image, but inverted. That's why magnification is negative, but image height and object height are same. So magnification -1, this can be a 1 mark question. Other than this, so we understood that magnification positive means virtual erect image, magnification negative means a real and inverted image. What if magnification is a number greater than 1. This will indicate that height of image is greater than height of object. So we have the last case of image formation in case of not last case, between C and F, at F, and between F and P, the image formation. In case of concave mirror, we have a height of image greater than height of object. And what if magnification is less than 1? Magnification less than 1 indicates that height of image is less than height of object, and this is the exclusive case of convex mirror. In case of convex mirror, image is always smaller, size of image is always smaller than size of object. And in case of concave mirror, when object is at infinity, image size is small, and object beyond C, then also image size is small. So these are the sign conventions for spherical mirrors.